And we're going to use a distance formula, but there is a piece of this that you need to make sure that you understand. So this distance formula right here is one that you guys know from geometry. Okay, and one thing you need to make sure you do know is the formula, because it won't be given to you. It will not be given to you. Okay, and when you minimize a radical, what you are minimizing is the radicand. Do you guys remember where the radicand is? Yeah, it's underneath the radical. Okay, so the radicand for the quadratic was b squared minus 4ac, the discriminant, right? So it's really easier to remember just the underneath portion, so we're going to call that capital D. And this is what we're going to use to basically take the derivative. Eventually, we will need the distance formula. Okay, so I'm going to show you how you're going to use this, and then you guys are going to do the second problem on your own, and I will show you the work. All right, so here we are given a hyperbola. Hopefully, you'll remember what that looks like. Basically, you have an ellipse, which is, if you think about it, is two parabolas that are going together like this. The hyperbola goes in the opposite direction because it's subtraction. Okay, so then you have a distance between the two vertices, and they open up in the opposite direction. That's just basically how I think about it. And here you're given the equation for this specific function, and what we want to do is find the points on the hyperbola that are closest to the point. Well, so much for that. Closest to the point 2, 0. So since we're looking for the closest points, we want to minimize the distance. Okay? All right. And then we actually need to find the closest distance. So we're going to find that distance in part B. Okay. So if we're using this formula right here, okay, for part A, what we want to do is plug in basically what we know. So here we have the point 2, 0. So this is going to be x1, yep, y1. Okay, and we're going to use this formula right here. So we're going to say that D is equal to the quantity, I'm using this formula, of x minus 2 squared plus y minus 0 squared. I know what that's equal to, it's just y squared, but I'm just showing you that we're plugging in. Because this isn't always going to be 0. It could be 1, it could be 7, it could be anything. Okay, so all we did was plug into the radicand portion of the distance formula. So the issue here is that once we simplify, we have two separate variables. So I'm just going to simplify this. I'm going to FOIL this first and then obviously simplify this. So we have x squared minus 4x plus 4 plus y squared. Okay, so our issue here is that we have our other variable y squared. So we need to make a substitution. And the way we're going to make the substitution is if I go back up here and I solve. So if I solve for y squared, that means I'm going to add x squared. So we have y squared is equal to x squared plus 4. So now I can take this and substitute in here. Okay? So now we have our distance formula is equal to x squared minus 4x plus 4 plus x squared plus 4. Okay, so I just made the substitution from up here. Okay, now it's not always going to be y that you substitute in for. It might be your x. You just have to see. And oftentimes what's going to happen in these types of problems is that one of those values, like this in the coordinate, is typically 0, so that way you have a singular. Okay, bless you. All right, so because we want to minimize the distance, we're going to take the derivative with respect to x, but before I do, I just want to combine my like terms. Yes, no? Yes. So this is d is equal to, what is this, 2x squared minus 4x plus 4. Okay, so now we want to take the derivative. So it's the derivative of our distance.
Plus 8.
Oh, thank you. Ooh. Plus 8. I'm already thinking that the constant, though, when I take the derivative is going to go away. That's bad, though. All right, dx. We're taking the derivative of our distance with respect to x. So what's the derivative of 2x squared? 4x. Okay, here. And then my 8, which I wrote as a 4, is a 0. Okay? All right, so everybody good? So we need a critical number, right? Okay, I already got, everybody's like, it's just 1. So 4x minus 4 is equal to 0. You said x is equal to 1. We want to minimize the distance. So if we use the second derivative test, if I took the second derivative, so it looks like this, it's just what? It's just 4. Okay? Now remember, this is when you have something this easy. I don't even have to do any testing. So remember, when the second derivative is greater than 0, meaning the second derivative is positive, what does that mean about the concavity for my original function? Concave up. So if we're concave up, do I have a min or a max? I have a min. So that was my test. So this is by the second derivative test. So does everyone see why I used it? It was just quicker. I didn't have to plug in anything. I mean, plugging in wouldn't really have been that difficult, right? But what happens when I plug in? Oh, well, I mean, you would have to do more tests. But here, this is a min. So when I write my conclusion, I'm not going to say by the first derivative test. I'm going to say what? Okay. But it was very easy, was it not? Okay. So that would be an occasion when you would use a second derivative test on your own by someone, bless you, not saying use a second derivative test. If you didn't think about it, would it matter? No, you're going to get the same thing. You're just going to have a number line. No big deal. But this is just to show you that you have choices. Okay, so now that we know we have a minimum at x is equal to 1, it says find the points. So if I want the points on the hyperbola that are the closest to this given point, remember what I told you? The graph is going to look something like this and this. Okay, so that means I might have a point on here and a point on here. So I'm going to have more than one. Okay, so here I have my x value. I need to find the corresponding y value or value so that I can answer A. How am I going to get those? Plug into the original. Which original? There's a lot of formulas on this paper. The distance formula? All the way up here. Yeah, all the way at the top. So we're going to use y squared is equal to x squared plus 4 when x is equal to 1. So here we have y squared is equal to 1 squared is 1 plus 4. So we have y squared is equal to 5. How many answers will I get when I take the square root? 2. Exactly, I will. We have, for part A, our x-coordinate is 1. We get positive square root of 5. And when our x-coordinate is 1, we get negative square root of 5. These are the 2 points on the graph that are closest to the point 2, 0. Meaning it is the smallest distance to this point. Okay, before I continue, does anyone have any questions as to how we got all this? Okay, so in part B, okay, it asks us what is the closest distance. So now we're going to go back to the distance formula, and I'm going to write it down because it's at the top. It is the square root of the quantity of x sub 2 minus x sub 1 squared plus y squared minus y sub 1 squared. I am pretty sure that if you look in your concept cards, these formulas are in there. I'm pretty sure. Okay, so here we have a point, right? And here we have a point. So this is where these values are going to come from. And if excuse me, if you notice, this is getting squared. So I'm just going to pick the positive just for now. So I'm using this point and this point to find the distance. So D is equal to the square root. What do you want x sub 2 and y sub 2 to be? Do you care? It doesn't really matter. So let me just make this 2 minus 1 squared plus 0 minus the square root of 5 squared. Is that okay? Okay, square root of 6 you said. So this is the square root. 2 minus 1 is 1 squared plus square root of 5 squared is 5. So it's the square root of 6. Okay, this is the distance. Now, we actually had 2 points. Can we assume that they are equidistant? They're probably not something that we can assume, but you would think when you draw. How many of you remember ever drawing the hyperbola? Okay. I know there was a conic section. I don't know who covered it in Algebra 2 honors. I think we cover it in pre-calc honors. I don't know about regular pre-calc. But the point is that it is equidistant. But if you forgot that concept, what would happen if I plugged in negative square root of 5? This just becomes 0 plus the square root of 5. Wouldn't this answer be the same? Yeah, because you're going to square it. So it doesn't make a difference. This is your distance right here. I just wanted to show you that. Okay. So does anyone have any questions on how I got anything here? This is the process is the same. So what you're going to do right now is you are given a parabola, and we want to find a point. So how many answers are you going to have? 1. This gives you the clue. 1. There's no S. Okay. There's no trick here. Okay. On the parabola, plus a parabola is only one graph, where a hyperbola was there were 2 pieces to it. Okay. An ellipse would have the same situation maybe if the point was on the inside of the ellipse. You guys know what an ellipse looks like? It looks like a football. Okay. And here, it's the same thing. Now, I am going to give you a hint, and I will go through this. To find a critical point, you have to use synthetic division. Okay, so this is P over Q, and I did show you how to do it. If you get stuck, I'm going to go through it with you. But what I want you to do is just try it. So I'm going to give you, I don't know, do you think 7 minutes is enough? 5? We just did it in like less than 5 minutes. If you get stuck, then you just stop and we'll get to it together because I'm going to do it with you. So don't get freaked out or frustrated or whatever. Talk to somebody. What would you do? How do I do this? I did talk to you about synthetic division, P over Q, didn't I, before? Okay. What typically did I say I start with always? What should you always try? What goes into anything? What is everything divisible by? 1 and... No. Negative 1. Yes, 1 and negative 1. Those are always my go-to because they're always a factor. Try positive 1, try negative 1. Just try them before you do anything else. Okay? All right. A little bit after 10. Bless you. I couldn't even tell you what class they're from. Not a clue. Who's stuck? Okay. Said who's stuck?
And then
Have I done what?
where was
When you are getting your zeros.
No, I know.
Okay, guys, here we go. All right. So, first of all, we have our parabola, and we have the distance that we want to minimize to this given point right here. So we want to get as close to 0 and -3 as possible. And there was a hint to find the critical points, use synthetic division. Here is the equation for our parabola. Okay, so we're going to use in part A. Oh, I forgot the biggest thing. What did I forget to do here? No one said anything. Yes, my justification. By the second derivative test. This is terrible. By the second derivative test. The distance at x equals 1 is a relative min because, and now this is going to be a little bit different because we use a second derivative test. Remember, d prime of 1 was equal to 0. We got our critical number of 1, right? And in our second derivative, d double prime of 1 was what? Greater than 0. Okay, that's okay. But I forgot this. That was terrible. All right, does everybody have that? Let's not forget it this time. That's my reminder here. Okay, so we're going to use the capital D formula just like we did before, and we have these points. So we have x minus 0, whereas in the previous problem it was y. So it's x minus 0, the quantity squared, plus it's y minus a -3. So this is y plus 3, the quantity squared. So we've got d is equal to x squared plus, and I'm going to FOIL this out, y squared plus 6y plus 9. Okay, and then I need to make the substitution here. Remember last time we had to make the substitution for y in terms of x. Now we need to make it for x in terms of y. So if I solve this for x, x is equal to -y squared. Because I can't solve for negative x. I just need to solve for x.
You can't say y squared equals to -x? Then this probably...
Well, but this isn't negative. This is positive. Because I need to take this x out. So we've got -y squared squared plus y squared plus 6y plus 9. Okay, this is why we're going to have to use synthetic, because this comes out to y to the 4th power. Okay? Well, that's the whole point. That's why I'm going through it. Okay, so in the previous problem, at this point, what did I have to do? Yep. In this case, I'm taking the derivative of our distance with respect to y. So this is 4y cubed plus 2y plus 6. I don't know, I could factor out a 2. So this is 2y cubed plus y plus 3. But the problem is I still can't factor this because this is not a quadratic. So you had your hint up there, and before you guys got started, I suggested you start with positive or negative 1. How many of you started with positive 1? Okay, did you get a 0?
Yep.
With positive 1? No.
I did it right.
No. If you start with positive 1, I'll just do it. Do you take this coefficient here? No, you take this, and what do I have to put in the spot for y squared?
0.
Exactly. So you've got 2, 0, 1, and 3. So when I bring down the 2, 2 times 1 is 2, I add, I get 2. Okay, 1 times 2 is 2, I get 3. 1 times 3 is 3, I don't get a 0. So this doesn't work. That's okay, I just wanted to show you. So then what that means is if I go ahead and use negative 1, I'm going to grab the same coefficients. Okay, bring down the 2. Okay, so negative 1 times 2 is negative 2. I add, I get negative 2. Negative 1 times negative 2 is positive 2. I add, I get 3. This is negative 3, so this is 0. Okay, so what that means is that negative 1 is a critical number. True? Okay, so as a factor, that would be what? Y plus 1. Okay, and then this polynomial right here is 2y squared minus 2y plus 3. If I have additional critical numbers, I would have 2 factors of 6 that add up to negative 2. 2 factors of 6 that add up to negative 2. I don't have that many factors of 6. 6 and 1, 2 and 3, I'm just about out, right? So then I would try, what would you suggest I try? Because I could tell you, and that's not going to make a difference. This is problem solving.
Right. Quadratic formula.
Yes, okay, the radicand in the quadratic formula, which gives me the discriminant. I want to see if these answers are even going to be real before I waste my time using the quadratic. Do you guys understand what I'm saying? So if I use, if you want to write it, you can, b squared minus 4ac, I'm just checking to see if this number is what? Positive or negative. Okay, b squared is going to be 4 minus 4 times 2 times 3. I'm going to stop here. Why? Yeah, it's going to be negative. So these answers are imaginary. So in terms of our critical number, we only have 1. Okay. So we're saying that y is equal to negative 1. That's our critical number. Don't make me laugh. That was so disgusting. Okay, so, sorry. I'm going to use a second derivative test again. Let's get it together. So when I take the second derivative, I'm using this right here. Okay? And I just want to be consistent with what I did before. We have, I'll just use d double prime, because we're going to evaluate it at negative 1. That's our critical number. So we've got, what, 12y squared plus 2? So I'm looking for concavity. And because we want to minimize the distance, we want this to be concave up or down? Exactly. We want it to be a minimum. So when I plug in negative 1 squared is positive 1. This is 14. So d double prime at negative 1 is equal to 14, which is greater than 0. So that means negative 1 is a minimum. We just use a second derivative test. Okay, did you have to? No, you did not. Okay, so before I forget it, let's write our justification by the second derivative test. Okay, the distance at y equals negative 1, and I'm just copying from before, is a relative min because d prime at negative 1 was equal to 0. That means we got our critical number from there, right? And d double prime at negative 1 was what? Greater than 0. Perfect. You guys are awesome. Okay, so in part A, I just need to get my x value, right, for that point. So I have my y value. We found it at negative 1. Where am I going to get my x value from? Yeah. So we have x is equal to negative y squared. So we have x is equal to the opposite of negative 1 squared. So what's my x value? Careful. Negative 1. Okay, so there is the point that is the closest to 0, negative 3. And then in part B, I have to use the distance formula. So D is equal to, now there's really no guess. Let's use the point that they gave us first, just like we did before. So we have 0 plus 1 squared, because it's minus a minus, right? Plus negative 3 plus 1 squared. So this is equal to 1 plus 4. So it's a square root of 5. Is that right?
It's negative 3 plus 1.
It is negative 3.
No.
Okay, questions? Okay, now do you see how synthetic division works? Yes? Okay, I didn't say you had to like it. I just want to make sure you saw how it works.